So in summary, hydrogen peroxide vapor is a benchmark for the spiroviral gas in aseptic processing environment. Probably 95% of applications still use VHP. There are different forms of it, and we're now starting to see, the so-called dry fog application of it as well. And I will cover various aspects of that and that comparison, because they are different processes, although they use the same starting material. And you really because it breaks down to safe components of oxygen and water, that's why it's such high up on the selection list. Chlorine dioxide, nitrous dioxide, whatever, nitrogen dioxide, they all have a toxicity. 0.1 ppm is classically these OELs, so it's much harder to contain in an isolator. 1 ppm of VHP in an isolator, that's very, very poor at passive diffusion. This is why we can gas rooms without too much concern about containment risks. If you fumigated a room with formaldehyde and there was a leak at a door, and this room was in the middle of a facility, you probably would even smell the formaldehyde when you walked into the facility. It diffuses that readily. With hydrogen peroxide, because of the passive diffusion and these hydrogen bonding characteristics, so-called sticky molecules, bond into water in proximity, these elements prevent the easy distribution. So consequently, a leak at a door, probably a meter or two back, it's not moving any farther, so it's much easier contained. Hydrogen peroxide vapor has been used in hospital wards when the ward next door is occupied. Its safety profile is a lot higher, and that's why it's been used. The physical chemistry is well understood. It has this 6-log sporicidal capability, and there will be a question: is it good enough as a surface sterilant to sterilize feeder bowls? And we will talk about that in another session. You need to optimize the process to minimize the amount of peroxide that you create. A very badly developed cycle will give you much more biocompatibility challenges than you need. The material selection will impact your endpoint because of the amount of absorption and desorption, and that applies as much to the filling line or the polymers that they use, your gloves as well. You would not use for a biological product a sip-sip system with a silicon tube, because that silicon tube would be exposed to hydrogen peroxide, and that would leach through and impact your biological product. That has been the case before. So the analytical methods are now being developed. You need to use them in a summary process design to be able to deal with that.